Okay, so what we just saw in those examples is summarized in this table quite nicely. So I'm going to read it, and then the best way to understand is to do the examples coming up. So how do we determine the radius and the interval of convergence of a power series? So it says use the ratio or the root test to find the interval on which the series converges absolutely. So that's what we have been doing. The radius of the convergence for the series in that case is r. And then here are the three possibilities. And the last step is what you're going to see in the examples coming up. That means checking at the endpoints. So that's what he's talking about, that we have to check the endpoints. So you read this table slowly and carefully, and we'll see example of each kind. So it's very important that you pay good attention to these examples. So what we are going to do is find the interval of convergence and all the steps, all the two steps. So let's start with the first one. So we're going to use the ratio test. Now notice that the geometric series test or the geometric series approach is not going to work here because we have k factorial, and geometric series works very rarely, so we should straight away usually go for the ratio test. So in the ratio test, the first thing is to find this ratio. So this is step one. So this would be x to the power k plus 1 over k plus 1 factorial, and then divide by ak, so that would mean k factorial over x raised to the power k. So again, you've seen enough of this stuff. So you would have, let's go through the steps. X to the power k plus 1 over x raised to the power k. So keep the x terms separate from the k terms. So this is k factorial, and in the denominator I have k plus 1 times k factorial. So this cancels, and here obviously x to the power k cancels, and I'm left with absolute value of x times absolute value of 1 over k plus 1. Step 2 is take k going to infinity. So now you notice this time we have the k plus k term. So therefore I have absolute value of x times absolute value of 1 over k plus 1. Now as I take limit k going to infinity, this goes to 0 for all values of x. Now the important thing to notice is that whatever x is, as long as you have k in the denominator, this is going to go to 0 for all values of x. And this is my L, and this is less than 1 for all x. The reason I'm repeating this for all x is that means that my interval of convergence in this case is minus infinity to infinity. In other words, this power series converges for all values of x. So my interval of convergence is this, and the radius is infinity. and there is no endpoints to test because the endpoints are negative infinity and infinity, so there's nothing to test in this particular example. So the answer is this is the interval of convergence. Next, now I have x minus 1 raised to the power k times k factorial. So if you see the similarity with ck x minus a raised to the power k, you will notice that ck is k factorial, and from here you can see a is 1. So let's see if it really turns out like this. So again, we're going to use the ratio test, and so step 1 is take this ratio, so that comes out to x minus 1 raised to the power k plus 1 times k plus 1 factorial divided by ak. ak is simply x minus 1 raised to the power k times k factorial. So simple algebra will show you that this is x minus 1. There are k here and k here cancels, and here I'll be left with k plus 1. Again, let's split it. X terms in one absolute value and k plus 1 in the other. Step 2 is we have to take the limit k going to infinity. So what do I have? X minus 1 and k plus 1. Now here's the thing to notice, that since k is in the numerator, if x minus 1 takes any value other than 0 and k is going to infinity, this is going to go to infinity if x minus 1 is not 0. On the other hand, if x minus 1 is 0, then 0 times anything that goes to infinity. So even if this is going, k plus 1 is going to infinity, as long as x minus 1 is 0, we are going to get 0. So this goes to 0 if absolute value of x minus 1 is 0. So if it is 0, the limit, then clearly it converges. Whereas if this happens, it diverges, because L is supposed to be less than 1 for convergence. So what we see here is that if absolute value of x minus 1 is 0, we have convergence. But x minus 1 absolute value equals 1 means what? Means x is equal to 1. So that means the interval of convergence is simply one value 1. And what is 1? This is the center of the power series, which is not surprising. So a power series always converges at the center, so the interval of convergence is only one point, and if that is the case, R is 0. So if we go back to the table, this is this particular case. If R is 0, the interval of convergence is the single point x equals a. And this example that we just finished before this was the first one, where R is infinity, the interval of convergence is negative infinity to infinity. Okay, let's go to the third example. So here, again, we are going to start with the ratio test. So the algebra is a little bit intricate in the sense that I have to do a little careful writing, but it's not that big a deal. So what is a k plus 1? So wherever I see k, I'm going to write k plus 1. So we have x raised to the power 2 times k plus 1 minus 1. Denominator is 2 times k plus 1 minus 1. Then divide by ak. So divide by ak means multiply by the reciprocal. So that is 2k minus 1 over x raised to the power 2k minus 1. Okay, so let's clean this out. So 2k plus 1, 2 times k plus 1 minus 1 is what? 2k plus 2 minus 1. So that gives me x raised to the power 2k plus 1. Denominator is 2k plus 1. And here it's the same. Now let's split it. So let's keep the x terms together. So x raised to the power 2k plus 1 is x raised to the power 2k times x divided by this is x raised to the power 2k times x to the power negative 1. And then the k terms are 2k minus 1 over 2k plus 1. Now this can be the x terms. This and this cancels. This can come up. So I get x squared, absolute value of x squared. And there's nothing much you can do about this one. So we keep it. So this is my ratio. Step 2. Now I have to take limit k going to infinity. So I have absolute value of x squared. By the way, absolute value of x squared and x squared is same, because once you square it, absolute value means nothing. Now 2k minus 1 over 2k plus 1. So I'm going to divide the numerator by 2k. Actually, I can divide by k. Doesn't really matter. And 2k plus 1 divided by k. So that is 2 minus 1 over k divided by 2 plus 1 over k. Now we are ready to take the limit. So as k goes to infinity, this guy goes to 0, this guy goes to 0. So I'm left with absolute value of x squared and 2 over 2. So this is my L, and this must be less than 1. So step 3, my L is less than 1 for convergence, which means absolute value of x squared is less than 1, which means that x absolute value is less than 1. which means I'm in the interval -1 to 1. Center is 0, therefore radius is 1. So interval of convergence is -1 to 1 and R is 1. Now we have to decide whether it is what happens at the endpoints. So the step 2 of finding the interval of convergence, we have to test at the endpoints. Now this is the first example where we are coming across testing at the endpoints. So please pay attention. So first endpoint is x equals -1. So I'm going to go back to my power series and I'm going to put x as -1. So what will I get? Summation -1 raised to the power 2k minus 1. Remember, x is -1. So when I see x, I'm going to write that. Divided by 2k minus 1. So what does this give me? -1 raised to the power 2k times -1 raised to the power -1 over 2k minus 1. Now -1 raised to the power 2k. Now 2k is even. So therefore this will always be +1. Whereas -1 raised to the power -1 is -1. So I'm left with -1 over 2k minus 1. So now we are in chapter 10. This is the kind of series we used to see in chapter 10. So the question is, does this converge? Well, by now I think you would have good intuition how to check this. So you're going to use limit comparison test and you're going to compare with bk as 1 over k, and you will find that this one does not converge. So use limit comparison test, use the comparison series to be 1 over k, and we will find that this diverges. So that means x equals -1 is not good. So at x equals -1, the power series diverges. So that is the conclusion. Now I have to check at the other point, x equals 1. Now at x equals 1, I'm going to put x as 1, so I get 1 raised to the power 2k minus 1 over 2k minus 1. But this is simply 1 over 2k minus 1. But again, this is very similar to this except for a negative sign. Now this one, again, simply by limit comparison test, we will see that this diverges. Therefore x equals 1 is also bad. So in our interval of convergence, both -1 and 1 are not good points because the power series diverges. Therefore your final answer would be that the interval of convergence is skip -1 all the way to 1 and then skip 1. So this is your final answer. Now let's go to the next power series. Same idea, ratio test. So let's find this ratio. So we get we can do it straight, x plus 1 divided by 2. So step 2 is take k to infinity. So limit k going to infinity, but this time round there is no k, so when you take k going to infinity you just get the same thing. So this is my L, and this must be less than 1 for convergence. So step 3 gives me the interval that x plus 1 absolute value must be less than 2. So this means that x plus 1 is between -2 and 2. So if you subtract 1, you're going to get x is between -3 and 1. So my interval of convergence is somewhere from -3 to 1. The center obviously is -1, and distance to the endpoints is 2. So my interval of convergence is -3 to 1, and the radius of convergence is 2. Now this is tentative. We have to check at the endpoints. So to know exactly what the interval of convergence is, I have to check at the endpoints. So let's first go x equals -3. So at x -3, let me write down the power series again. X plus 1 raised to the power k over 2 raised to the power k. So for x, I'm going to write -3. So I get -3 plus 1 gives me -2 raised to the power k over 2 raised to the power k. So this means I have -1 raised to the power k times 2 raised to the power k over 2 raised to the power k. So this and this cancels, and it's simply a series -1 raised to the power k. But what kind of a series is this? There are a couple of ways of looking at it. One is pretty simple common sense, that if you have -1 raised to the power k, then what you're getting, if you put 0, you get 1. If you put 1 k, then you get -1, then +1, then -1, then +1. So a series like this is obviously going to diverge. Another way to see it is that this is a geometric series with r as -1. Now if r is -1, then it is obviously going to diverge, because for convergence absolute value of r must be less than 1, and we don't have that. Okay, so At -3 we have divergence. Let's go to the other point. X is 1. So if X is 1, now in this power series I'm going to put X as 1. So I get 1 plus 1, which is 2 raised to the power k over 2 raised to the power k. But that just means summation of 2 over 2 raised to the power k, which is summation 1 raised to the power k. Again, this is 1 plus 1 plus 1, which obviously diverges. Or you can think of this as a geometric series with r as 1. So again it diverges. Even if you had cancelled it here, you would have gotten summation of 1. Summation 1 means 1 plus 1 plus 1, which clearly diverges, adds up to infinity. So you have divergence here also. So therefore, your final interval of convergence for the power series is exclude -3 and exclude 1. So it's open interval from -3 to 1.